Chapter 9 Exercise Set, Problem 1. Here we go. According to a report published by Gallup Institute on February 20, 2020, which is based on the series of interviews that took place between the February the 3rd and the 16th of that year, 77% of 1,028 randomly selected American adults felt they were generally confident in the federal government's ability to handle a potential coronavirus outbreak. Find a 98% confidence interval. Okay, here's the process. Step 0 is the decision-making process, and a lot of students will just skip over this and go to step 1. That's because this is proportion problem and it's got to be z-curve. Go right in. That's okay, but here, let's take all steps. After all, this is a lesson, so we have to take all the steps. Look at the sample size of 1,028. That's much bigger than the threshold of 100, so we take z-curve. By the way, I have some comment about this 100. If you look at some older textbooks, the threshold is a little bit lower, like 50 or sometimes as low as 30. The reason is because t-curves are usually difficult to handle in terms of computation. And 50 years ago, people used to cheat with z-curve even for smaller sample size. And if you look at some older textbook or some new textbook, which was just copied from older textbook, which was again copied from even older one, you're going to see lower threshold like 30. Not very good. So modern threshold is about 100. In any case, 1,028 is much higher. Okay. Now let's go to the initial picture, and here we go. If you use your paper and pencil and your hand to draw, please follow this process. Outline, center, end, and finally shade. Outline, here we go, normal picture, symmetric, unimodal, kind of like this. And the center is the expected value, 77%, so we have 0.77. End, we are looking for the endpoint of this interval here and there, x1 and x2. And finally, we shade, 98% in the middle, and consequently 2% have to be shared, 1% here and 1% there because of the symmetry. Again, from the symmetry, the distance from the center to the left-hand side endpoint and center to the right-hand side endpoint must be the same. So if you just find out one, you can find the symmetry to find out the other. Just change the sign and you're going to be... Okay, all right. Let's go over to the next step, the real solution part. We use the formula number 1 of this course, z equals to n minus center over SE. But then again, what is SE? The standard error is this one, formula number 2 of this course. SE is equal to square root of p times 1 minus p over n. In this case, 0.77 times 1 minus of that over the sample size of 1,028. Don't forget the square root. If you do everything and punch in the calculator, you're going to get this number. So we get n minus center over SE, and you'll have to set it up with appropriate z-score. And that is going to be your z-score, but how did you get that? Let's find out, and let's open up the z-table. Okay, here's the z-table, and here are all those numbers. All these are left-hand side shading, so you have to find out 1%. And here we go. Negative 2.32, and then negative 2.33, 0.0102, 0.0099. So the real z-score must be somewhere in between. And that's how I estimated negative 2.325. Negative 2.325, like this. After that, all I have to do is just solve this equation. Flip the denominator to the other side, so this z-score times SE. And then flip this 0.77 to the other side as well, and we're going to get this expression. All you have to do now is punch in the calculator. If you do it right, you're going to get this number, 0.7394 something about 74%. Now, we found out this endpoint here, and all you have to do is to use symmetry and change the sign, and then we are going to get the second. And here we go. Instead of minus here, change this to plus and run your calculator. You're going to get about 80%. There goes your confidence interval. And here is the graphical justification. Here we have 98% there, and x1 and 0.739 something, about 74%, and then about 80%. That is 98% confidence interval. What does that mean? Under this normal approximation, there's about 98% of probability that real proportion falls somewhere here in this confidence interval. And of course, there's about 2% of chance that I'm going to miss this. 1% over here, 1% over there. All these are based upon the normal approximation. If the normal approximation somehow fails, then nothing works.